So, what if I told you that a 300-year-old puzzle about the very layout of our solar system might have already been solved? Today, we're digging into a pretty controversial paper that claims to have done exactly that, using something the author calls a unified field theory.
Right, so this puzzle, it's called Bode's law. It's this deceptively simple formula that for a while seemed to perfectly predict the distances between the planets. For centuries, it's been debated, celebrated, and, well, ultimately dismissed by mainstream science. But one physicist, Mathis, argues everyone has been looking at it completely wrong. Okay, let's dive into this.
First things first, we really need to get a handle on what Bode's law even is and why it has such a weird and fascinating history. It was this tantalizing glimpse of some hidden order in the cosmos that, for most people, just turned out to be a total dead end.
Okay, so the law itself, which popped up back in 1715, is ridiculously simple. You take a sequence of numbers, 0, 3, 6, 12, and so on, just doubling it each time. Then you add 4 to each of those numbers. And the crazy part, that pattern almost perfectly matched the distances of all the known planets from the sun. It was uncanny.
And this right here shows you both the magic and the problem with the law. For the planets from Mercury all the way out to Uranus, the predictions were shockingly close. It even predicted there should be a planet right where we later found the asteroid belt. I mean, it was nailing it. But then, the pattern just completely breaks down. For Neptune, it's way off, and for Pluto, it's not even in the same ballpark. And that is why most astronomers just threw up their hands and walked away from it.
Yeah, because of those big failures, the modern consensus is pretty clear. Bode's law is just a mathematical curiosity, a fluke. It's considered so settled that the top planetary science journal, Icarus, flat out refuses to even look at papers on the topic anymore. The door is shut.
But Mathis comes along and says this dismissal is a huge mistake. In his work, he claims the law isn't wrong at all. The problem, he says, is that its underlying math has been totally misunderstood for centuries. So he proposes we rewrite the whole thing from the ground up.
So, Mathis's first big move is to just throw out that simple doubling sequence. Forget about it. He claims the entire pattern is actually a function of the square root of 2. And he argues this isn't just him playing with numbers. It's a constant that pops up naturally in the physics of rotating systems, which would tie the sequence directly to orbital motion.
And that leads to his core idea about the mechanics of it all. See, a planet's position isn't just about its orbit around the sun. He says each planet also rides on the orbits of all the planets inside of it. You can kind of think of it like a set of nested gears. Earth's final position is determined by its own motion plus the summed-up motions of both Venus and Mercury.
Okay, but here's the twist. When you actually apply this new gravity-based formula, it does worse than the original Bode's law for the outer planets. The errors get huge. And Mathis just says exactly. He argues that these big errors aren't a failure of his model. No, they're proof that a second, totally unaccounted for force is at play. And he claims he needed to create that room in the math to fit it in.
And this intentional error brings us to the most radical part of his entire theory. Mathis argues that gravity isn't the only game in town. He introduces a second, universal repulsive force that he calls the charge field, a force he believes works against gravity to push the planets into their nice, stable orbits.
So according to Mathis, this field follows a couple of unique rules. First, a body's charge isn't electrical. Don't think of it that way. It's a function of its physical size and its mass. In his model, bigger, denser planets push other bodies away with more force. Second, this pushing force gets a lot weaker over long distances. And those are the core principles he uses to calculate how all the planets are constantly shoving each other around.
Okay, so now we get to the payoff. Mathis takes this two-force model, gravity pulling and this charge field pushing, and applies it to the outer solar system, the place where both the original Bode's law and his own gravity formula failed so spectacularly.
To really understand his model, you have to start with Jupiter. It's the key. When you calculate the charge of the outer planets using his formula, Jupiter is just an absolute monster. Its repulsive force is more than 6 times stronger than Saturn's, which basically makes it the big boss that shapes the entire outer solar system.
All right, so let's take Uranus as a test case. As you can see here, Mathis's gravity-only formula was way off. It produced a massive error of almost 31% compared to the actual orbit of Uranus.
But now he applies his charge field calculations. He factors in all those repulsive pushes from Jupiter, Saturn, and Neptune.
And the result?
Just look at that. The error plummets from almost 31% down to just 0.17%. Mathis presents this as his smoking gun. He says that huge error wasn't random at all. It was the precise signature of this missing repulsive force.
But he goes even further. He argues that the ratio of the error for Saturn compared to the error for Jupiter wasn't random either. He calculates the actual ratio from the real-world data and gets 2.4154. And his charge field equations predict a ratio of 2.4154, a perfect match, which he claims is basically impossible to achieve just by coincidence.
Now, it's really important to understand that Mathis doesn't just present all of this as some novel solution. He frames his entire body of work as a direct and pretty aggressive challenge to the scientific establishment itself.
He really doesn't mince words. In his paper, he describes the history of physics not as some story of progress, but as a, quote, wasteland of complete incompetence, arguing that physicists have been stuck going down the wrong path for centuries.
And he fully expects a hostile reception. But he attributes it not to scientific disagreement, but to what he calls a corrupt system of sinecures, where tenured academics are more interested in protecting their jobs than pursuing the truth. He actually claims his work is actively censored by search engines and ignored by journals for this very reason.
So, that leaves us with a pretty fascinating dilemma. Is this a revolutionary unified field theory that solves a 300-year-old problem with some surprisingly simple math? Or is it just an incredibly elaborate case of finding the exact patterns you were looking for? The source material makes its case, and the final judgment, well, that's up to you.